Okay, let's implement these two optimizers together. Initializing the accumulation is the same for RMS prop. So we're going to use this part as well. And this one is also similar. However, the difference is rather than just accumulating these values, we have one more step. We are multiplying the decay factor, decay rate, to the previously accumulated gradients, and then 1 minus self decay factor rate to new gradient. And this part is just the same. Okay, let's move on to Aram. Here, we need to initialize this part first. But at this time, we're not just, so let's say this one is V, and V. However, we also need to initialize the momentum like this. And let's repeat this for momentum as well. And here, for Aram, there are many formulations to implement this equation. And I'll show you another one in this implementation. First, we need to increment the number of iterations we've done. And we are going to update the learning rate first by multiplying square root of beta 2 raised to the power of iteration divided by beta 1 raised to the power of iteration. So in this case, we are multiplying these factors to learning rate. And we are going to use these, not going to use M hat, but just going to use M and V. We do not want to touch M and V, but just let them stay there. That's why we are separating these bias correction terms to learning rate. Okay, that's why we are doing this. And for key in params keys, what we are doing is we first need to update our momentum. This is going to be 1 minus 1 times Grad's key minus self key. Okay? And you can expand this equation, then you will see that this corresponds to this one. And for accumulating the gradient, we are going to take a similar approach. Or you can implement this in this way. Self beta 1 times self M key plus 1 minus self beta 1 times Grad's key. You can take either of these options. However, the first line, the commented line, is equivalent to this line. Okay, then what we are doing is to the key, we're using the bias correction learning rate rather than the learning rate we have here. Okay, so we are learning rate T times self M key divided by MP square root of self, the accumulated gradient. And because we are dividing, we need to add a small number for numerical stability. You can also separate this LRT from these two bias correction terms, and you can just unbias M and V on your own. However, that could complicate the computation, so we are taking this operation. All right, up to this point, we've discussed optimizers.